Electrical energy from the ocean. Solar energy reaching Earth is responsible for differential heating of the atmosphere and thus air circulation as wind. Some of the energy of wind is transferred to the oceans, where it causes waves and is partly responsible for oceanic currents, although Earth's rotation also plays a role in currents. Gravitational attraction between Earth and the Sun and Moon generates tides, and, along with Earth's rotation, causes most coastal areas to experience a twice-daily rise and fall of sea level. In short, the oceans possess a tremendous reservoir of largely untapped energy. If we could effectively harness the energy possessed by the oceans, an almost limitless, largely non-polluting energy supply would be ensured. Unfortunately, ocean energy is diffuse, meaning that the amount of energy for a given volume of water is small and thus difficult to concentrate and use. Several ways of using ocean energy are being considered or are under development, and one is currently in use, although it accounts for only a tiny proportion of all energy production. Of the several sources of ocean energy, temperature differences with depth, currents, waves, and tides, only the last shows much promise for the near future. Ocean water at depth might be as much as 25 degrees Celsius colder than surface water, a difference that allows for ocean thermal energy conversion, OTEC. OTEC exploits this temperature difference to run turbines and generate electricity. The amount of energy available is enormous, but a number of practical problems must be solved before it can be used. For one thing, any potential site must be close to land and also have a sufficiently rapid change with depth to result in the required temperature difference. Furthermore, enormous quantities of warm and cold seawater would have to circulate through an electrical generating plant, thus requiring that large surface areas be devoted to this purpose. The concept of OTEC is more than a century old, but despite several decades of research, no commercial OTEC plants are operating or even under construction, although small experimental ones have been tested in Hawaii and Japan. Wind-generated ocean currents, such as the Gulf Stream, which flows along the east coast of North America, also possess energy that might be tapped to generate electricity. Unlike streams that can be dammed to impound a reservoir, any electrical generating facility exploiting oceanic currents would have to concentrate currents' diffuse energy and contend with unpredictable changes in direction. In addition, whereas hydroelectric generating plants on land depend on the rapid movement of water from a higher elevation to the turbines, the energy of ocean currents comes from their flow velocity, which is at most a few kilometers per hour. The most obvious form of energy in the oceans lies in waves. Harnessing wave energy and converting it to electricity is not a new idea, and it has been used on an extremely limited scale. Unfortunately, the energy possessed by a wave is distributed along its crest and is difficult to concentrate. Furthermore, any facility would have to be designed to withstand the effects of storms and saltwater corrosion. The Japanese have developed wave energy devices to power lighthouses and buoys, and a facility capable of providing power to about 300 homes began operating in Scotland during September 2000. Perhaps tidal power is the most promising form of ocean energy. In fact, it has been used for centuries in some coastal areas to run mills, but its use at present for electrical generation is limited. Most coastal areas experience a twice-daily rise and fall of tides, but only a few areas are suitable for exploiting this energy source. One limitation is that the tidal range must be at least 5 meters, and there must also be a coastal region where water can be stored following high tide. Suitable sites for using tidal power are limited not only by tidal range, but also by location. Many areas along the U.S. Gulf Coast would certainly benefit from tidal power plants, but a tidal range of generally less than 1 meter precludes the possibility of development. Even areas with an appropriate tidal range, such as the Arctic islands of Canada, offer little potential because of their great distances from population centers.